we can talk about streaming in a second here. Hey, welcome to Coffee Compiler Club. Here to talk about compilers and or language runtimes and or ecstasy versus AA hacking and whether or not Cliff is streaming or not or something. We were just talking about streaming things just a minute ago, and I don't know. I still think watching streams looks like paint drying, but apparently there were a bunch of people who watched, so there you go. Everyone's heard this before. We're all getting recorded. Done.
Yeah, well, for me, I'm not a big watcher of programming streams, but it is interesting to like get a sense of how people go about their work. So that part's interesting. I think once I have the sense of it, I probably wouldn't spend too much more time watching them, but it's
Does anyone here like, discover anything excitingly different? Hey, it's Emacs. What the hell? But not much else going on. And oh, Simon's going to be here. Okay, fine.
You type really fast if I speed it up fast enough.
Yes, and if I had a better keyboard, I'd probably go faster yet. I have this funny medical issue. Sorry?
I'm still looking for you.
Okay, used to be you could get 17 millimeter and 18 millimeter pitch keyboards. And somehow the world settled on 19 millimeters and my fingers are not there. They want probably 18 millimeters. So I miss key constantly. And it was whenever I switched keyboards, I gave an old mobile portable keyboard to my son years ago. That was the last time I realized that I was stuck now on 18 millimeter pitch. My fingers no longer make the 19 millimeter stretch. I can't change keyboards ever again. So I'm forever mistyping, and I would love to have an 18 millimeter pitch if anyone finds one.
Yeah. I do this thing.
Right. That looks like an 18 millimeter pitch. And I got, fairly new, if I can get this thing unplugged, this guy, but you can tell he's still 19 millimeter, just as wide as before.
Cliff, there are those maniacs, enthusiasts who make their own keyboards. Maybe that's
right. So I could find somebody who would custom make me one for like $500. I was like,
no, you can do it for way less. I'm one of those quote unquote enthusiasts. I have like a bunch of split ones that I made.
Well, I want a standard with 10 key, 18 millimeter, and if you can charge me less than 500 counting shipping, we got a deal.
Like if you want a standard keyboard, you can just buy ready-made ones, and you can get them for like $100, $200 basically.
With an 18 millimeter pitch, I could not find one with an.
I don't know what pitch in this case means.
If they don't say, they're always 19, and I hunted for about a month.
Oh, so, what is pitch in this case?
Think about it as center
spacing between the keys.
Oh right, okay.
Darrick,
so
hold up your keyboard.
Yeah, I have to unplug it. Hold on.
Okay.
Yeah. This is normal as well.
About the same height as my face.
We all need to hold up our keyboards. Let's
get
that as the thumbnail.
Almost surely. Well, I don't know. Simon's might be less than 18.
Yorick's keyboard's too small.
Yeah, it's one half of it. So, no. So typically, I don't think they use pitch as terminology. It's more the spacing is usually named after the switch types.
Yes.
So you get like.
Yeah, they no longer use pitch because everyone settled on 19. If you go hunting, you will find many people talking about 17, 18, 19 pitch. And then if you go buy, they all say, 19.
Right.
Yeah, it's basically it's like one unit and it's all the same.
Find a ruler.
But it's basically, if you want the keys to be tighter to each other, I think most mechanical keyboards are doing that.
But I have to go to a custom maker because I don't have a 3D.
No. Like if you want a standard keyboard where it's basically without the numpads, there are like hundreds of variations of that ready-made that you can buy like everywhere, like on the internet.
Right. Now go find one with an 18 millimeter. I think I found without the 10 keypad pitch variations, but I'd like the 10 keypad.
So just to be clear, York, the challenge is if one of the custom keyboards takes normal keycaps, then it's not an 18 millimeter because the keycaps are actually a limiting factor. So I actually have one keyboard. Actually, I have two.
It is 19.
I have two split keyboards that have a smaller pitch. So Cliff, if you're into split keyboards, once I get my new one, maybe I'll.
Yeah, no, that'll kill me.
No, so what you can do is, let me see, put it up close because it's black, so it's not
Right.
really visible.
Right.
This is where the keys are basically right against each other.
Right.
That's
I
a
have
different type of
space to
switch
shrink-
and keycap. But they exist, and put it this way: if you're paying $500 for a keyboard, you're getting ripped off.
like I said, I hunted. Well, I didn't, but I hunted for somebody who'd sell me one with 18. Here's somebody's trying to do me. Aaron's claiming Logitech. I couldn't find.
I'm just saying, what do you think of the compact layout Logitechs? That the whole keyboard's just smaller.
Right. So if you whip out your ruler and you count, you'll see it's a 19mm pitch. And I could use one, like I use the extra 10 key on all kinds of extra steps and gaming and things. I could not code with it. I know I use it coding, I just don't use it lots coding. Like I have a fairly, what was called a Logitech, this is Logitech keyboard I have, it's a compact layout, it's their claim, with a 10 key. Looks very similar to what you have there with a 10 key bolted onto the right. Still, that is still 19mm pitch. What you can do is you count keys across, 1, 2, 3, 4, 5, 6, 7, 8, and you get 2 fat keys and you have some count like 10 keys or 12 keys. Then you ask for the width of the thing and you divide and it comes up and it's really close to 19mm. And that's it, your 19mm pitch. So I go in there and I type and I miss key constantly. And as of 50, I started doing this. I got stuck at somewhere around my 40s and 50s with the 18mm in my fingers and my brain, and now I can't do it. It's been several years and I've not gotten used to a 19mm pitch, so sucks.
But you know, the best thing that I ever did for my keyboard experience, well, so I'm fine with the key pitch on mine, but I put a piece of leather underneath my keyboard and it softens the strike impact because there's a very shallow strike on this thing.
Right.
So I just have this like thin, it's like a 1mm
right.
piece of leather. Huge difference. If I don't have it, my fingers get tired like right away.
Well, I grew up.
I think I found one for you. It's a little small, but like.
Yeah, that's probably under 19mm.
No,
it's definitely under 19.
I grew up on
1.9.
IBM punch card keyboards, which required enormous strike force. So all my life, my fingers are used to striking enormously hard. And if you ever play one of these finger games where you do like this with people's hands, it's like I'm brutal. I'll crush big guys in seconds. It's bad. But everything else about me is built to scale, but fingers and wrist areas are too many years of brutally smashing keys. So I have a smaller one and it doesn't have much play and I smash it constantly. I'm curious now, the leather might be nice. It might feel good, but I don't think it'll stretch my fingers or have them stretch.
It's just
Someone's gonna have to cut out that 5 seconds where Cliff said, I've got a smaller one and it doesn't get much play and I smash it all the time.
That's just for you, Cameron. I'm feeding you straight lines so you get your chance on, LA Boulevard here. Fine. All right. Does anyone talk about something related to compiling as opposed to coding with keys?
Well,
there was a brief discussion in the channel about Forth used to replace its own interpreter as it was running.
Yeah.
And I was curious what people thought of self-modifying compilers that you start with something that's a little more interpreter-y and
Forth was the original self-modifying compiler.
Isn't any compiler written on the JVM effectively that?
Yeah, it depends on what you mean by self-modifying.
Especially if you think about starting
But the JVM JIT's not written in Java bytecode.
If you think about interpreter, then Growl maybe.
The Growl one is.
And Truffle. That's kind of what it does.
Yeah.
It takes an interpreter and makes a compiler out of it.
Yeah. I'm not claiming these are awesome compilers when you're done, but neither is Forth. Yeah. You should mess with Forth at some point. If you get far enough down the rabbit hole, it's not a deep rabbit hole. You suddenly realize you can. It's a DSL for writing DSLs. It's a compiler and an interpreter baked into one, and it's super trivial. There are just not much parts to a Forth system. I've mentioned before, it's often used as startup on tiny embedded systems because you can get everything done in no amount of code. It lacks strong typing, so that's a bitch, but everything else is kind of there. I guess it doesn't have operator precedence order. You get reverse Polish notation.
I mean, is there any reason that it would need to lack strong typing?
Not for what its current,
I would think it could become more strongly typed as it was running.
You could, yeah. Well, I don't see why not. There's
I mean, you start with something that's just basically assembly, and you get a richer and richer interpreter as you go that has more checking in it.
A lot of fourth self-hosting starts something like that. You have to provide in assembly or machine code about 10 function calls, and they do things like walk a string and split it into white space, but not make new strings. Just walk it and declare this is a start inhibit token, and do a hash table lookup, and do a jump to function that I got somewhere. And they're not too many things. Like I said, it's really tiny. That gives you a basic fourth interpreter. From there, all those parts can be written in itself, and then you can start building up from there pretty quick. It's a fun, it's like an afternoon project to go build a fourth interpreter and then go make it interpret itself or build itself. All right, somebody else said something.
Yeah, so.
And can you get to reasonable speeds that way?
It's not an optimizing compiler, but you can get to threaded interpreted, better than a tier 0 jet. Like a tier 0 jet, original fourth is interpreted. You can get to a tier 0 jet really quick, but you can go a little bit better than tier 0 jet without needing a real infrastructure overhaul. Yeah, all the Futurama projections. Yep. Somebody else throwing more keyboards in. I'll go inspect more keyboards in a second after the meeting or something. If any of the CCC watchers know where you can get an 18mm pitch, let me know. Where we're at? Oh yeah. So you can get reasonable, better than interpreter speed out of it. Darrick, you were going to say something.
Well, I had an exciting week because I am starting now on the second version of the compiler, and I got a whole pile of stuff done. So I've actually, I was borrowing a little bit from Simple and AA and building up a node structure, and this point
you're actually doing nodes in a graph.
Yeah, I'm doing it very much the AA style. I'm trying to make it so that
my zombie apocalypse is on.
Yeah, I know. So I'm trying to make it so that it's not actually immutable nodes, but I'm going to try and use them in an immutable way in practice so that I can have the benefits that I had from the previous system and just more by convention. We'll see if that works. I'm not exactly sure, but okay. I did a bunch of stuff, and I've got so in the previous version, I did this whole translation from Python to Lisp as a sort of pre-processing step.
Right.
And then I actually did some like macro expansion and various things. And then I went into the graph. And so it was actually about 20 nanopasses of stuff, right? So each nanopass could be like 5 or 6 lines of code, but they would all sort of walk over the whole AST, and it was a bit slow. Also, my Python ingestion had a lot of, wasn't very optimized, and it, for a big Python file, it would take over a second just to ingest the file, which was kind of painful, actually. So I just worked around it by caching everything, so at least while I was developing, it was fast. But I went and optimized that, and now I've got it still isn't super fast, but it ingests the same Python file in about 70 milliseconds, and then straight into Sea of Nodes, and that work perfectly. Like all that other stuff that I was doing beforehand, the only thing I'm missing really is the macro expansion. And so I'm just having to deal with a few more node types because like and or were previously pre-expanded into if type statements.
And ors or bit masks. What are bit
Like
masks? Yeah,
logical and so like
yeah.
like a and b would be, you know, if a,
Yeah.
you know, then if b, then return b, else false type of thing.
Right.
So yeah, so it's great. I've got a whole test suite running with lots of Python being parsed and into Node, and it displays. And I did a revisit of my rule system. So I'm trying to like improve the syntax. So
we talked about that last week, and yeah, fine.
Yeah, I can show you where I got with it because I'm pretty happy with it so far.
Okay. Hang on.
Oh, I have to screen share though.
Yeah, screen share. I have to enable it. Yeah, go.
All right. Two. All right, so can you see okay?
I wouldn't mind a lighter theme, but that's
right.
me. And a little, you got a little bit of a, there you go.
Yeah, okay. So
And a bigger font size.
Yeah.
How about that?
I've increased my window. I'm good, but they have other viewers, so maybe bigger fonts. Good.
Is it good now?
Yeah.
All right.
Good for me.
Okay, so it might be good to sort of compare how it worked before. So this is the new syntax, and then here's the old. So let's see if I can. Now the patterns here work, but some of this stuff.
Go find add of 0. I mean, on a trivial pattern that we all know what it's supposed to be doing.
Yeah. Okay. So,
because I don't read closure, so I'm
yeah,
just
yeah.
guessing.
I'm just finding it here.
You can pick a different op if it.
Well, so here's a simple one. So this is saying equality, and it's just the two nodes are the same.
Right.
So this should be constantly
true somewhere.
True. Yeah. So it seems a bit roundabout here the way I did it, but anyway, it's like create a const node on this graph, and for some reason I looked up the function for equality. I feel like I could have probably just put that in.
If I go down one layer, I see node rule equality, a question mark a. So this is if I have an equals of 2 A's, you keep running your mouse with this one, yeah. Then
This
you're going to
one,
return it const node true.
Yeah, that's right. Yeah. So that's
and I would claim that subsumes the constants.
Yeah.
Oh no, if you have two constants and they're different, then you're going to pre-compute something about them.
I think some of these are probably redundant. Like this one probably is the same as this one and could have been gotten rid of. So as I've been going through, I've found a few of those.
Yeah, okay. Well, now show the new style.
Yeah, or here's one where it's I'm saying, okay, there's some operator I'm looking up in this function, so it's like plus, minus, whatever, and both constants are ints, so then I can just compute it, right? So
gotcha. Right. And here's the equality on the other side. Do you say
yeah, so here it's a bit different. So first of all, I'm registering which phase I'm doing it in, and then I'm naming the rule set.
Okay.
Then here's a predicate that runs, so it doesn't even have to run the pattern matcher. I can just check the predicate to see if any of these patterns even apply. So running a simple predicate is way lighter than running the whole pattern matcher. So I can quickly select out, the 5 or 6 blocks of rules that I even need to run.
Okay, what's the predicate? How does the predicate work? Because I don't.
It just says it'll just basically, if it'll basically just say
Okay, so the whole stream in/EQ question mark is a token. So that's like a function.
Yeah, so this is
Like I said, I don't read closure.
yeah. So this EQ question mark is just saying this is a binary operation and the operator is equal.
Okay. And in/ means not or something?
N/ is the namespace, sorry. Yeah.
Oh, okay.
So
Okay.
that's just so it's just this function, but it's in this namespace.
Okay.
Yeah.
Okay, so if you're an equality operator,
yeah, so
yeah.
yeah, so then I run this set of patterns. So basically, here I can say if it's equal and they're both
Same thing.
the same value, then I can say this is true. And then I can also say, so I added another piece of syntax here saying, pipe something pipe is that means it is a constant. And I can say, well, if I'm doing equality check on two constants, I know that I've already checked that they're not the same, so therefore they're different. Therefore, I can return this is not equal.
Yeah.
And I don't need to know any more about it than that.
Okay.
So
you don't have two nodes with the same constant in the system at once. Two constant.
Yeah, that's right.
Okay.
Yeah. So yeah, there could be nodes that evaluate to the same type, but that won't be checked here because they're not constant nodes here.
Right. Yeah. Okay.
Yeah, so overall, I went through and I ported a whole pile of rules, and I haven't debugged all this yet. I was really wanting to see if this way of expressing rules actually works.
Right.
And then, but some of them came out really nice. So for instance, this if decided. So this was if decided previously, and here's if decided now. So it actually came out a lot cleaner.
Right.
So, basically I was able to say, okay, if this is truthy, I don't need to really care anymore about the predicate, so I can just do this sort of assertion on the node. And then I just grab the region and the other region. And then if it's false, I just grab them in the reverse order. So, and here I had a bunch of logic in line to determine if this is something that can get to the X of the program or not. And I just moved that into a helper. And so then I can create this as an if undecided, which just inserts replaces the if node with one that replaces the constant predicate with an undecided node. And that way it doesn't kill this if. So that deals with my while true type situation. Right. So so this says, I'm in something where if I kill the else branch, there's no way to get to the end of the program. So then I don't want to do that. So I make this if like officially undecided, and otherwise I can replace this with the region. So basically the if node can just be replaced by the region node, and that should all
for while true infinite loops, I just threw in a jump never, so it always has an exit path to the
I see.
And the profiler knew the frequency of it was never, but the optimizer left it in place.
Yeah, I think I accomplished the same thing by just having the predicate node not allow the if statement to be decided.
Yeah.
And so there's the jump that would never actually happen. to the else branch, which will then stay live.
So you left an if in there that you could have otherwise folded because it's looping around a while true somehow.
Yeah.
Yeah.
Yeah. So I don't know if that's like maybe I think when I built that, I was thinking that it was the same as what you did, but maybe what I've got is a little bit different.
It's not, it doesn't sound hugely different. There's
Yeah.
something that prevents the last if from folding away despite having a constant true test.
Yeah. Yeah, exactly.
Yeah, and that was, well, yeah, that was so I could keep the optimizer sane from having it detach the program from the exit and then not be able to find, when a backwards walk, find anything.
Yeah. 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 So in the previous rule engine, I would have all these sort of mutations that I would do within the rule body. I would say delete this, delete that. And this, some of these rules like this one were rules that I did very early on in the process, and I got better at it as I went. So I'm not saying that these are the best implementations, but
Oh yeah. There's always rewriting going on these things.
exactly, yeah. So, and most of the stuff never really got revisited because it worked fine. But now, porting over, I can clean it up. But one of the things that so I had this a lot, like throughout all my rules, I had like, set this argument, change this node in this way. And so sometimes the changes would be non-local to the node. And then I would have to just do this just return success that something has changed, even though maybe the
local
same node is actually still there, it's just changed. So I couldn't just return the node because then it would think that the rule didn't change anything and that wouldn't work. So
I worked around that or lived with that and ended up in the zone of, if I have to change something non-local, I want the rule to fire on the guy who's going to get changed. So he might look backwards instead of forwards.
Yeah.
He might count how many uses he has before he triggers something.
Yeah. And I found a couple where I realized that I had written rules like that and it was easy to rewrite them so that it just changed the node that it was, the rule just found the node that it was going to change in the first place, which seems better.
Yes.
But
yeah.
I came up in the meantime with this, which I think is a nice solution as well, where I could just, in this case, I could just return the region and say this node is going to be replaced by the region, and then the underlying mechanism will do that. Or I could return a map, and then here I could have potentially multiple changes, including I could say like if I wanted to, say kill. I could say like kill that node, and there's really no concept of creating a node that's not going in somewhere. So there's no like apropos of nothing, add some node. So that's never really a thing as far as I can figure. And so I can do multiple changes and have this map of what this rule has changed come back from the rule. And I think that's a nice thing. So then I can just create new nodes always. And the rule engine can say, well, can tell, okay, this and this and this is going to change. Usually it's just one node changing. And if it is one node changing, like for instance here, then I just return this new if statement, and it replaces the old one, and all fine. I think it's actually going to be quite a nice improvement, and it'll actually also help me with it gives me more information for debugging, because I actually have explicitly previously I could diff the results of my rules, but now I'll also be able to say this node is gone because it was replaced by that node, and I don't need to like figure that out for myself.
Yeah, my rules all have the thing that they say, I'll return what you're replaced by, but I
Yeah.
can't tell you a set of diffs that happen. There's exactly one announced diff. It's you got
Yeah.
replaced by that.
And so, you know, hopefully, you know, I think if you get the rules just right, you get there.
Yeah.
And sometimes the rules aren't as nicely defined and you end up with
Not as
multiple.
clean as you'd like. Yeah.
Yeah, so I want to, yeah, I think I'll support the multiple and hopefully I'll never need it. And then I can get rid
There
of
you
it.
go. Well, that was my add depths was, well, no, add depths covers the other direction. That's not fair. Add depths was about, I failed. And what did I fail on? I failed on because something further in the graph was not how I wanted it. If that
Yeah.
further in place changes, come revisit this rule.
Yeah.
Yep, yep.
And I haven't figured out how to do that in this situation because, for instance, if this rule almost matches but doesn't match, it's not going to have any side effects.
Right. So I have rules that say, like, I have an if, he tests a predicate. Well, I'm going to go look up an approximation of the immediate dominator tree, looking for another version of an if that has the same test. Specifically, this is for Java's repeated null checks, but repeated range checks and repeated whatever checks. People do it all the time. It happens. So you get repeated checks. You get a repeat. You can replace the down one, the start of the point, with whatever true or false side he fell when he hit the upper guy.
Yeah.
But you have to walk an approximation of the immediate dominator, and that makes you very non-local. So you walk a while and then you fail. It didn't get it. So what do you want to do now? Well, if something changes up there, maybe I can walk further and get a hit.
Yeah. So one thing is that I don't actually, you know, I have this rule engine. It's meant to serve me, not me to serve it. So if there's some rule that I want to do where it just doesn't help me, then I can just do it in some other way.
Just bail out and write your closure code.
Exactly.
Yeah, my
so
peeps are, I've tried to arrange that the tooling is such that I kind of sort of have a DSL for writing people rules, but as soon as it fails me, I'll just bail out and go write some Java code.
yeah.
Yep.
Yeah. Another nice thing that I have that I built here is I have this alternate representation of nodes. So I can set in, normally I do this n equals or n type pattern, which says, okay, it gives me this sort of S expression like representation of a node where it's like the operator and then all the arguments positionally.
Yeah.
But I can do an M variant where it gives me a map. And so here's the operator and then all of the things named. And so I actually built that right into the node structure. And because I realized that I could do a lot of interesting things with this unelock that you had, or I just called it unlock. I think Simple called it that.
I mean, it was edge lock, so it was unlock the edge lock.
Yeah.
Right.
So I've got this cached node map here that it's a closure map. I originally actually used a hash map, but it didn't play as nicely with closure, so I changed it. This is what I wanted to use it for.
What's the map between?
Yeah, so it is this representation, and so if the nodes are locked, it makes this once, and it'll just cache it. But then when it unlocks, it clears that, and it'll just remake it the next time. So that's nice because previously I would make these types of things thousands of
my
times.
node name, my field names too.
Oh yeah, I mean, why not?
There you go.
Well, keeping the field names consistent actually helps me understand when I'm looking at looking at or whatever simple. So I do some things the same and some things different.
Some things different. Yeah.
But
okay.
So one thing that I really like is I've got this set of keywords, or it could be strings. Keywords are just a type of intern strings anyway. and I create it here. And then this is what I use to create this map. So the map is just called named here. And
you have
I
a
decided,
keyword
since I don't do
mapping.
Java, and I would just see what it's like to adopt the Cliff style.
I don't think this is very Cliff style at this point.
You don't think this is Cliff style?
Oh, it's style, but it's not. Oh, I see what you're talking about. You mean style in terms of my coding style?
Yeah,
The Cliff normal form.
exactly.
Oh, I see. There you go. Well, okay.
Yeah, so why not? So I don't have my
Yeah, it
own.
looks good to me.
Yeah, so it's nice and terse anyway. So here I I build up this map, and I just basically, the way that you initialize one of those closure maps, you create an array of key value alternating, and then you just init the thing with it. So I do that. But like if I look at a node
moved from Clojure to Java for performance reasons?
Yeah. So so here actually, let me get rid of this. So here I actually have a node where I can create this load node, and here are the two inputs that it could have. It has an address and a source. And so I initialize, so the region, address, source. But then here I have this array of names, and so basically here I can tell it how I'm naming it.
Yeah.
And then when it generates the map, it generates them named. And so I have these accessors as well separately. I'm not sure if they'll actually be necessary, but it's kind of nice because I can actually just get things by name. So I can hit input name.
Yeah.
And it just keeps things clean, because that was one thing that the not having things named was a big part of the reason why I avoided this sort of node form where everything's this positional indexing.
Oh, I use the accessors to avoid the positional indexing thing.
Yeah. So exactly. So I build these accessors as well. But yeah, this was, I don't know, I thought it seems like a kind of nice, it's actually similar in a way to the way that your tuple node works. Although, yeah, like I discovered that sort of similarity later. But anyway, I'm pretty happy with this.
What's your font game doing an Emacs? You have greater or equal as a single lexical character.
Oh yeah, I don't know. I actually don't know how to turn that feature off.
Okay.
I can turn it off on an individual buffer level, but I can't
doesn't look unequal. Doesn't look terrible because it's still two characters either way.
Yeah, the thing that really bugs me is in Clojure it replaces FN with a lambda.
Oh.
And that's, yeah, it goes from two characters to one character, and it messes things up.
Right. Yep.
Anyway.
Interesting.
So
I had seen, up a line and input name, if I greater equals 0, you got them greater equals jammed together, which is fine, except it's interesting to me. That's like one character in the display, and when you're editing it, it is two characters.
This one is, yeah. And if the lambda did that, then I'd be happy with it, but it doesn't.
Okay.
Yeah.
Wow.
Yeah, you can kind of edit them. Yeah.
I assume when you start to edit them, it unwinds here.
Yeah. So I can, change it, but yeah.
Oh, people talking mechanical keyboards. All right, I'll go read mechanical keyboards later. All right, well, why don't we, you got more you want to show, or we wind it down?
I think so, yeah. Was there anything else? Not really. I mean, I decided to try and make this distinction between the in, which is 0 indexed with the region, and then input, which is 0 indexed without the region.
Oh, ouch. Well, there you go. Good luck with that.
Yeah.
I use the name thing though. The name hack seems interesting. Other than I don't want to put quotes to get a name in there. I'd like some way to have it feel more property-like without being a property.
So does V2 output better code than V1 did, or is there sort of different ways to do similar compiles?
Well, I'm targeting the next generation of our chip. It's quite changed, but one of the
So a little
problems,
hard to one-to-one compare.
well, also I've only worked on it for a week, so
But
so it's not putting much code yet.
I thought one of the goals was to run faster as well, or compile faster.
Exactly. So yeah, I for production compiles, I need to be able to compile 1,000 little programs. Oh yeah, sort of on the order of 1,000 little programs. You know, so that can't take all day.
Gotcha. Is Simon on still? Yeah. Were you going to show something? Because you had a bunch on Discord. You were putting up links to slides and stuff.
Oh, I don't think it's ready yet. I mean,
It's never ready. At some point, you have to show anyhow.
Yeah, but I don't think it's something for today. Maybe for next week.
All right, fine.
Also, I could be in France.
Yeah.
Have to check.
Okay, next topic.
Yes, someone got something. Otherwise, I don't have a good thing. I've been hacking AA in the last several days and homing in on the differences between two different variations of typing theories that I'm sorting out. But I'm lost in a twisty maze of typing theories, so it's not a good thing to present. No one got anything? We'd be early done.
I mean,
I thought you had already escaped the typing labyrinth.
I kept coming back around to it. It was now you're gonna get me saying something. I have a version in a one standalone file that types. It doesn't do all the things I'm trying to type. It does most, and it has an execution, a CEK engine, it's a variant of a SecD engine. And so I can run and I can type, and that looks exciting. And then I go over to the AA code base and it didn't go. So I went back and forth. What was I doing different between the two? And it turns out I'm doing several things different that look interesting. And I you know, once again, I bit off more than necessary, and, you know, second system issue. So the observation I've made is, if I look at C structs, they have a mapping from field names to values. If there are no side effects, it's more like a ML struct or a closure struct, mapping from names to values. If I look at a stack frame, it's a mapping from names to values. If I have single inheritance classes, then I have a mapping from name to values at one level, but I could go up a class hierarchy and get another level and up until you run out of classes. If I go to stack frames and I have a mapping from names to values, if I allow myself to use
You're saying
values
the class hierarchy and a stack frame is the same thing?
Yes. So then I went ahead and AA and did that and said, all my stack frames are actually just standard objects, structs, and I have only one struct kind typed thing, and I use it for both stack frames and regular structs that you would declare as a struct and do things with. And they both have a single inheritance flavor to them, so they can both have up to stack frames. And I'm trying to do ML typing on an SSA graph. And when I run through that and was, you know, manipulating things, I kept finding things I was doing different AA that had it be more like C, but it wasn't typing identically to the ML I was getting out of the EXE, the short easy guy. And that turned into, there are places where in the ML typing, you're going to make what's called a fresh copy of a type, and that's let polymorphism. So once the type is declared, once the value is declared, and you use it, everywhere you use it, you get a fresh type pattern. So you can take a map, and he can be a map from ints to strings, or a map from floats to doubles, or a map from Persians to salaries, or whatever. So he's a new type at each use point for the map. So when you declare a map, he gets, so that happens. When I mixed when you do that typing the normal way, there is an environment that you're carrying during the typing process, and you use it during lookups to figure out where identifiers land and whether or not they should make a fresh copy or they should be a static, the same value, the same type. And I wasn't doing that identically in the AA side because of the differences in the mappings was subtle enough that I got confused about where the mappings would go or not. And I'm passing that environment into functions so they can act like closures. And if, of course, if you just do stack like things, then the optimization says I don't need to pass it in. But every function call in C gets a stack pointer passed in. Stack pointer is carried along anyhow. So identically, the stack pointer gets carried along explicitly in the AA typing and typed, and that turns out to match identically to the environment you're using when you're doing Hindley-Milner typing as part of the typing process, except that the places where you do fresh or not behaviors vary, and I wasn't getting it right on the AA side. So I went to the Hindley-Milner side and I changed the typing algorithm and the SecD engine to pass arguments into a function as opposed to the standard Hindley-Milner is you would build a new environment, call the function in the new environment with the arguments basically squished in the new environment, just slides things around. So I'm in the middle of all of this, and I have almost every test passing on the EXE side with it changed to look like what I'm doing in AA, except I've got one guy who's got two sets of cyclic recursive types that are being unified, and I don't get the unify right, and that's because I rewrote the type unifier to clean it up, 2 weeks ago. Well, I put a bug in when I cleaned it up, and I'm diagnosing that bug. So once that happens, I'll probably have, once again, types between, I'll have the EXE side nailed. It's nailed. I think it does everything I want it to do. And the AA side is now very similar to the EXE side, and the differences will be exactly what point I need a fresh type or not is a little different than what I'm doing in AA right now. And I'll have my pattern from EXE. That'll just be a one-to-one match, and I'll say, wait, here and not there, and I'll be done. So yes, in the sense that I think I'm not doing typing theory research, I'm doing implementation. I changed my implementation on my research piece, introducing a bug that I'm now chasing down. And I changed it to match what I'm doing what I want to be doing in a production coding compiler environment. And I'm trying to make those two systems look identical enough that I can carry the typing over and match the typing in a compiler that should behave like a C compiler in the end. We'll see. So that's a work in progress. It'd be very boring to stream it. Maybe not. Maybe you would love to see it, because I'm at the point where I'm going to draw a large, complicated graph. I have a half here. I don't know if you can see it. I need a sharper pencil. I need colors. So I might actually auto-generate the nice things we're getting out of simple with, whatever the graph viz thing, and stare at two cyclic recursive types and unify them and confirm where I made a mistake in my unifier.
But it sounds like you're not ready to start writing a standard library and getting a
No.
meaningful amount of code that you can start to tell whether this type system is easy to use or not.
No. I have tiny test cases that fail instantly because they're not doing the right thing. But I think I've worked out how I want to do primitives. I worked out how I want to do overloading. I worked out how I want to do, I think, class hierarchy as well in the Hindley-Milner setup side of things. I'm busy unifying the concept of structs and stack frames, and I'm the tail end of that piece. So I'm hoping in the end I'll have fewer nodes and fewer concepts, but they'll be interlinked better, worse, something. So that was my hack last several days. And when that winds down, I will switch to ecstasy, and that's probably what I'll be on Monday again. Sometime I'll be on either simple or AA on a stream. I'll try the live stream once a week, see how it goes. I have to cut my screen size in half. I have to double my font, cut my screen in half, so I get like a quarter of my viewing area. So it changes my coding style. And then I have to respond to people asking questions. So that's another interruption. So certain things work well in that environment, certain things do not. What I did the last 2 days would not work well in that environment.
How many live viewers did you have while you were doing that?
Oh, I think it peaked at like 12 or 13. I don't know. For a first time, no announcement thing, I thought that was pretty good.
Yeah, it's a lot.
So I will make more effort to promote next go round. Although I don't know how. Guess I didn't post anything on Twitter. So you had to be on the coffee club list to get a notification, which is really, because I was just testing. So I was just like, how does this work? What happens here? And then suddenly people showed up. I was like, how the hell did you find this live stream? I got a notification on Coffee Club. Well, good thing I'm wearing clothes. Fine.
Okay, Yorick, you was about to say something.
Oh yeah.
Oh yeah, I had a very different topic, code formatting, which is everybody's favorite topic amongst keyboards and text editors.
No.
No, so there's a technical.
Cliff's already in pain on this one this week. So
So basically, I'm working on a tool to automatically format Inca code. I'm basing this on the design that this tool called Prettier uses. They based it on some paper with some name I forgot. So there's some science behind it, basically.
Radler's pretty printing paper.
Sorry?
Probably. Radler's pretty printing paper.
It could be. It was a fairly recent
Haskell
one.
related.
But
Okay, then
the
maybe
sort
not.
of idea there is you kind of construct a sort of separate tree with like operations like, oh, group these things together, and it then tries to fit them on a line, and if not, it will wrap them, and you have like sort of markers where you say this is where you can wrap, etc.
Put your link, or Matt, come up with a link.
I don't remember what the paper title was, but so I have a decent amount of it working. So far it does like imports, constant definitions, and a couple of other things that sort of occur at the top level of a file typically. But for that I already need some more logic because, for example, constants can be arrays of, say, integers, but also arrays of arrays. So there's already some logic in place there to essentially handle arbitrary expressions. And so far it works quite well. So I'm fairly confident that this will not reveal any sort of big problems down the road. But it poses this interesting question where how to format basically arrays. Because there's inconsistencies there in how languages do it. So in my setup until today, it was basically you have your array, you have your values. If they fit on the same line, just do that. If they don't, put each value on a separate line. And then the formatting sort of works recursively. So if a sub value doesn't need formatting, it stays on one line, right? That approach works very well if they are expressions like method calls and all sorts of things. But it gets kind of annoying if you have like a lookup table, which is like a big array of integers, for example. An example I have in some code is an array of 255 ints. They basically say, hey, if this, it's basically a map of bytes to some thing. And what I did there, I manually formatted that such that I basically had as many values on a line, and then I sort of manually aligned it, because at that point that made it a little easier to figure out. But then you get the question with a formatter, should you basically fit them, fit as many values on the line, or just split them across multiple lines? And it's a surprisingly tricky question, because if you format them across lines, it is fairly straightforward to implement. And the diffs, if you make changes, are absolutely trivial to understand. And for me, that's a big plus. Like, you look at it and you see exactly what has changed and nothing more. In contrast, well, the downside there is, this table with 255 values, that's going to need 257 lines for the opening brace, values, and the closing brace, basically. And so I have this sort of test file where I had a couple of constants with like different arrays or whatnot.
So
and basically the choice between fit
that I
as
thought
many.
was interesting that I saw in one place that I don't know if you want to copy or not is look at what the person did before the first element. If they did open brace, new line, then they've sort of indicated a desire for lines and the whole thing out. But if they did the dense thing, have no new line before the first element, then that's sort of an indicator that they want the density and pack them all in a rectangle.
Yeah, so there's a Zig does something like that where
Use white
by
space,
default,
guide where you put the white space.
where Zig doesn't actually wrap your lines. What it does do, if you have like an array and the last value has a comma, it does wrap it. Now, I personally despise that because for me, the point of a formatter is to basically kill this entire debate of how should I format my code. The answer should be run this tool, shut up. Right? And if you give people those kind of configuration options, what's going to happen is, Alice, Bob, and Eve, they're going to write code. They have different settings, and your code is going to look inconsistent. Now, of course, opinions will differ. Some people don't like that. That's perfectly fine.
We were just having a kind of a nasty fight on this. I have to throw this out. I have never seen a coding style save a project, but I have seen coding style wars break teams.
Right. And
That
that's
was
where
definitely not a nasty fight. That was pretty tame. It still wasn't pleasant, but that was as tame as I've ever seen one.
No, and I think for me in the end, like I think most people can agree that the style you choose itself is very subjective, and so in the end, it doesn't really matter what you pick as long as you're consistent with it. So whether you use tabs or spaces, I don't give a shit.
I agree with you, Yorick. I think that is an excellent way to approach it. The problem is anytime you have a team that has more than one person who doesn't agree.
Right. But that's the beauty of a tool that doesn't allow options. Like, oh, sorry, the computer says no, right?
Right.
That's something I found in GitLab as well, where
yeah,
if
right.
you
So
put
I'll just block Yorick, and you won't have me on your team, and that's it.
Oh, no, that's
Well,
that's a perfectly valid thing, right?
Also, people may reject your language, right? Because they don't like the fact that you constrain them.
They're glad you could join.
I think that's perfectly valid. I think my answer to those sort of cases, like, well, if something as superficial as that is your breaking point, then honestly, you're probably not really going to be beneficial in the first place.
Maybe
well, it's not superficial, I mean, I work in a company where
go format
people have very there's a very rigid coding standard of how it should be written. And so people are very specific about, and so if the language forced you, that would be unacceptable.
Right. I think ultimately that comes down to, who do you want to cater to? In the sense that, do you want to cater towards every possible use case? Or are you going to cater towards sort of your, I don't know if you would even call it a vision, but your idea, basically? And I don't think that's the right answer, right?
Yeah. So I kind of think that there's this concept of you should follow the rules, especially like when you're a beginner. So like a beginner should be like very rigidly following the rules because they don't necessarily know why the rules are there. But at a certain point, you get to a point of mastery and you realize that you don't like some of the rules and you have good reasons and that you should be able to adjust, right? And because you can improve things. I think maybe some people have, they have basically arbitrary reasons for doing what they do, but like per code format, I mean, it's basically the medium that you're working in. It's quite relevant, and I think someone has, like, I actually have always been on this sort of similar side as Cliff, where I like my code to be very dense and terse, and if someone hands me a file where there's like new lines between every statement, it really bugs me because I'm like, I can only see a fraction of what I'd be able to see at a time, and it reduces my ability to work effectively.
Yeah.
So, for me, like, I like that density, and it's like, I feel if I'm like, it's kind of like if I'm reading a book and I'm measuring myself by number of pages I've read per day, then, if I have a book with a giant font, it makes me feel really good. But like, in terms of getting like the most value from what I'm doing, sometimes having that information density is useful.
There's in the chat, there's Aaron pointing out, rules of poetry writing and a poem for the sake of a single poem. And there is a thing here that says there's
it
some
actually
artistry.
applies quite well to programming languages as well.
There's an artistry to writing code, and the formatting says you don't have any artistry choice here. You must only code in the brutest Soviet block style for buildings, for instance.
Yeah.
And it's just like, come on. So I am not of that opinion. I am of the opinion that people should write in whatever style lets them be the most productive. And then your code gets split into different painted colors. And if I'm coding in your piece of code, I'll honor your style. And if you code in mine, you honor my style. And if I abandon the code and the code has no owner and somebody needs to fix a bug and they pick it up, they do what they want.
Right, no, and I agree with that in the sense that I think that the prime example is how people sort of format their curly braces in like C languages. So it's like, K&R style, element style.
XC style.
Right. Yeah, the weird one where like the braces are indented.
Braces are indented and down a line. Yes.
I think in the end there, it doesn't really matter which one you pick because it is subjective, right? It's similar to like how different people prefer, I don't know, different styles of paintings.
It's not subjective.
Oh, no, it absolutely is. Like whether you prefer one, that is a subjective choice. Now, there might be a valid reasoning behind it. Right?
Okay,
you might
that's
argue,
fine.
hey,
The braces on their own line is objectively better. And
Yes.
the fact that they're balanced, so they're vertically aligned, is objectively better. But
Exactly.
I also understand that it's not what other people do because 50 years ago we had smaller green screens. They were 9-inch green screens, and it was 280 by 156 or whatever resolution. So they didn't use blank lines because it was too expensive on the screen, and that's the era that
Yeah.
Cliff is from. Cliff
I used blank
invented
lines
the
as
first
well.
CRT.
No, for me, there is so many years of ingesting code of a particular style that I am just much faster if I'm reading my own style. There is a measurable quantitative difference in how fast I can grok your code versus mine. I looked at Darrick's Java node class written in CNF, and I could just instantly pick apart exactly what was going on at the whole screen at once. That was a snapshot. Oh, I got it.
Cliff, isn't that like your argument right there? Isn't that actually an endorsement of having exactly one formatting style across the entire ecosystem? Because that way, if you get used to it, you'll be able to read and write anyone's code.
All right, now it's too late for me.
Yeah, yeah, right. So you're basically saying you don't learn new tricks.
As long as York picks CNF, we're all good.
No, so you could argue for days whether something's subjective, objective. For me, the idea that basically if there's proof, like somebody did the study, that A is better than B, different story. But I think my point ultimately was with the arrays example. The common convention that you see is what people do is say, hey, if this is an array of say interfloats, simple literals basically. Fit as many on the line, otherwise, we span them across lines. Because if you have like arbitrary expressions and then some get squeezed on the line and some not, that looks really inconsistent and it's actually quite painful to read. But it turns out that from a technical perspective, that's actually surprisingly difficult to implement. This notion of break when you hit the line limit. Because for example, the way this algorithm works is you sort of construct your tree. And then when it's time to print it, you do it sort of recursively. And as you do that, you keep track of how many characters do we have on the line, and then when you reach these sort of group nodes, that's where it says, "Hey, can we still fit it? If not, wrap it. If yes, etc."
Yeah.
So there's some recursion going on there, and you then have to calculate widths, which, if you take into account Unicode, is linear. So not just, hey, get the length of this field. It's you have to actually calculate graphemes.
Just popped into my head, and I'm curious what you think of this. But like, I was just thinking about different styles, and Cliff's style is characterized by density, but also very short variable names. On average, I would say.
I use long ones from time to time.
Long ones from time to time, but I would say that
He occasionally uses 2 characters.
The median variable is like 5 characters or something. And
now the median's not 1, but I'll say it's probably less than 5. The median.
Yeah, something like that. And then
he rewrote code the other day while we were online together because he had one variable that was 5 characters long and he had to shorten it.
Yeah.
3.
You remember that he's got the wrong size keyboard and it's hard for him to type.
It is.
So
Not sure there's a correlation there, but okay, fine.
Anyway, like maybe to inform what you're going to do in your code formatter, you should look at statistics on the name sizes that the coder is using, and as they get shorter, you should make your code format denser.
Oh, interesting.
So that would make everybody happy, because like someone who's really doing like one character names, 2 character names is going to be really annoyed when every line has 2 characters on it. But the person who's using 40 character names wants everything to have 3 spaces between the line.
Yeah.
My suggestion is,
but then you end up with like different files basically being formatted radically different based on whether it's Bobby or Eve who last touched it.
It's consistent, and then you can sort of find a place in the team where you've got like kind of a reasonable naming, because your formatter doesn't actually address naming, and my theoretical formatter does.
Okay, so I have to ask, is this genuine or is this sort of a slightly sarcastic?
No, actually, it's an idea that I'm not going to write it.
Right.
But I
would
actually
be curious
think that
to
there's
see what
germ of an
happens.
idea there.
But
I think
I have other
think
constraints on a code formatter, and I have been in systems where you had to have code formatting, format for push before. There's other problems, including like endless white space thirds for people shuffling white space around, stuff like that. So there's things to be done here yet, but I don't want to go that path because I just went that path and I don't want to do it again.
I think you should go with putting it on each line, because you've given the reason already. It makes it easier for code to be diffed over time. If you had to choose one format, you should go with that.
Right, so that
breaking up
I
arrays,
think before I was tackled, that's kind of where I was going for that. And this is not just format, it's sort of generally speaking, the line-oriented approach makes diffing very straightforward, at least by default, because there are some tricks. Whereas I would say column-based approach, it is more painful to diff, but you sacrifice less vertical space, so it might be easier to read in source code form. And so it kind of depends on, is this value going to change a lot? Or precisely, is it going to change more than people are going to look at the thing as a whole? So for example, if you like a big lookup table as an array of ints, chances are that's not going to change that much. But chances are people are going to look a lot at the file that it is in. And it's kind of annoying if they like scroll through first 400 lines of integers because of this array being wrapped across multiple lines.
I think an array.
You're writing
with,
SHA-256. The constants table is not going to change.
Yeah, and if the kind of array you're describing is not an issue. I think the issue is like if you have an array which has got, say, values which are subarrays, like three. Let's say the array is like it looks like a table. Like you have 3 values on each row, right? Because there is some kind of substruct or subarray. In that situation, the column structure is very nice, because you can then, you're diffing at each line, because each line can only have 3 values, right? But now if you were to then say the sub rows, sorry. Now if you then say the sub arrays are now broken up into individual lines, you're making it harder for people to read and diff, and
in fact,
so it's really difficult to make one single choice. But
I would exceed the normal line length in order to make subarrays fit on a line, and then have them internally add spaces so they element by element line up as well.
Yeah, and the alternative of, decorating your code with, pound suppress rewrite or pound suppress warning. Sometimes I'm working on C projects and there's more pound suppresses than there is code. Not mine, by the way. I don't suppress anything. I just ignore it.
There is an artistry in writing code, and things that fuck with that artistry aren't necessarily helping anybody. I mean, the goal of the code printer pretty printer was to help the team understand. And if it messes up your artistry that's presenting a particular aspect, like the 2D alignment in the table, it's not helping. Sorry.
No, so that's that's coming back to, like, I think in the end there's a million different styles that you can pick. It matters less which one you pick. It matters more that you pick the one, for example, the context agrees upon, whether it's the team, the language, whoever you're trying to target, basically.
Yeah.
But I do think it's, whatever you pick, extremely important that you do not give people the option to start changing that for themselves.
Okay.
Because what you end up with is you have, say, 10 files, 8 are formatted in the same style everybody has agreed upon. And
Yeah,
then
but
Billy
that's
says, you know what? I don't agree.
you're
I'm
right,
going to
you're right,
format
you're
these
right.
two
You said
files
it.
differently.
You just said it, that everyone has agreed upon. You won't get agreement. You will not get agreement. Having not gotten
Go
agreement.
proves you're wrong, Cliff. Go proves you're wrong.
So you might not get agreement, but you can, I don't know if it's the right way of phrasing it, reach a decision. An example here that I remember from my GitLab, not related to code form, but a similar sort of thing. We had a particular workflow for dealing with security issues and security patches. And this involved you basically going through a bunch of checklists. And some of them were really stupid, like, did you add this label? Yes, check. And this was based on sort of what we determined was necessary, people agreed, etc. But what happened over time is that people felt there was no need for certain steps, or they disagreed with it, so they would leave it out. And what then would happen is, depending on what steps they omitted, that would impact the people doing releases.
It doesn't sound like a code formatting. It sounds like security wall.
No, so these steps, they were not strictly necessary, or in the sense that what happened is people were supposed to add a label. They did, but they didn't check off the checkbox, which meant that depending on what the steps were, if you as a release manager had to review it, like, hey, is this ready to go? You now actually had to do extra work.
Yeah.
And so what we ended up doing there is, rather than getting everybody to agree, we had certain people agree, but not the entire company. We basically had this bot, aka sort of a code formatter, come in and absolutely complain about the most heinous things. Like, it said, hey, you added this label, you didn't check off the checkbox, fix it, assign it back to you. It was incredibly pedantic. And there was no way of opting out. And what happened is people initially be like, this is annoying. We're like, well, the computer says do it. This is what the process is, right?
I'm okay with that. There are things that makes sense on. I'm okay with that.
Right, and I am, this is where we differ. I'm of the opinion the same applies to formatting. Like, you pick a style, that's the style. Yeah. No exceptions.
Okay. All right, can we agree to disagree and move on?
I mean, perhaps that should be really a editor thing, where the Git stores or any source repository stores one style, but when you check it out, you see it in your style.
Yeah.
And if the formatting is not robust enough to survive reformatting across style, then that probably is a problem with formatting in the first place. It's that brittle.
Just had this discussion, as my thesis is I've yet to see a formatter who could 100% unwind, go to your style, go back to this neutral, go back to my style, go back to neutral. I've never seen what could 100% unwind. It does have some lossiness.
Well, with suppressed comments, you can get there to the extent that if you can survive with suppressed comments.
You throw suppresses, as Cameron says, you throw suppresses in everywhere, or you throw it in the whole file and it's just not there. It's just the same as didn't bother with the formatter in the first place.
Suppress comments, suppress modifiers, suppress annotations, or suppress keywords.
Yeah, right. You drown in them. What the
hell?
Just
put them in unsafe.
Couldn't you just explain what you want to ChatGPT and get it to format it for you?
There you go. That's what I want.
I was going to make the Allen joke, but I figured it would have already worn
out. Wow. So another piece of this is my my very long history of autism, very high functioning autism, goes to my ability to have an emotionally charged, for me, emotionally charged conversation to negotiate things like coding styles. It's too much effort mentally for me to do that beyond a very small amount. And literally, I will walk before I'll deal with somebody forcing a process that I don't agree with. If somebody comes to me and says, and this is the process, this is the wrong job for me. If we ask, hey, what about process? Let's negotiate, have a discussion, and we can keep it clean and level and come to an agreement. I'll agree. If I can agree, then I do, and I'm good. If not, it's not worth the fight, and it's not worth dealing with the disagreement. I'll just walk.
It's worth saying as well, though, that when organizations accommodate differences among people, they are also asking others who didn't have a say in that to accommodate that accommodation. So there is a balance, and there are some intractable equations in there. So you've at least mentally accepted that, you know, for you, it's no hard feelings, you're going to walk. A lot of people don't get there, and so they just fight it out until everyone hates each other. So
right, that's what I said. I've seen it break teams because they're going to fight and not either walk or yield. Not worth it. So no compilers today. We're all about coding styles.
Depends, you know. I mean, I'm working with your coding style, even though I don't like it.
Oh,
I
you
guess
modified mine. It's not my coding style now.
But you know, I mean, a lot of it is not my style. But you know, the way I see it is I look at the bigger picture. I see that what we're trying to do is great, and I don't mind. I think, okay, I can live with this.
There you go. That's what I did too. And I live with the extra indentation and the super long names where it doesn't bother me. Fine. I wouldn't take that name. There are a couple other things we've changed that I would disagree with, and I let it ride to get a tutorial out. So I
Exactly.
agree.
So I think you are saying you are more flexible than you think you are. As long as you if you don't feel that people are kind of overriding your preferences.
Oh, there's that too. There's the I wasn't consulted thing. But in this case, I know this material like the back of my hand. So I can read the funny style, for me, funny style, and know exactly what's going on. Whereas when I'm coding the ecstasy code, I'm in new terrain. I know how it should go, but I'm actually cutting new things. Same with AA, I'm cutting a lot of new ground. And I do not want to have the coding style mess with my understanding, so I can get a deeper, quicker understanding of what is the problem I'm actually trying to solve. Coding style, while changing things like there while I'm trying to solve a hard problem, just adds more difficulty to an already hard problem. What's the point of that? Coming back later and saying, okay, this code's been stable for 2 years, reformat it. Maybe I've walked away, and if I've walked away, I've walked away, and I don't care. You format your heart delight. So right now, I know this code you do. I'm okay with where we're at. It's fine. I'm in it for the greater good. Coding the ecstasy stuff right now, I'm doing my super dense, super tight style because it helps me understand what's going on.
Yeah, so York, one other thing on some of your discussion of this, I've noticed a lot of the things that the formatters really struggle with are context across multiple lines. And that's the one to divine somehow. And actually, I think that's where, don't beat me up for saying this, I think this is where Alan would actually be right, saying that a LLM would actually be better at predicting where you would put your words. But that said, I'm not going to waste,
going to the LLM thing, I think it's true, because if you step back and think about it, it's a fuzzy problem without clear definitions, and that's basically what AI does, right?
It rewards itself for guessing right and figuring out why it guessed right.
Yeah.
I don't think it ever figures out why it guesses right. But it does reward itself for guessing right.
No, but there's a correlation. For example, that example of the buff dot append or whatever. Why is it indented only 3 characters this time? Because it's buff dot, and buff is 3 characters, right? So the dots line up.
Yes.
Right. So an LLM would figure that out. Figure it out as anthropomorphizing it, right? But there's a correlation.
Yeah.
And it would have
to line up. Not necessarily has to do with the buff. It's getting the dots to line up.
Exactly.
Yeah.
So
The
it
thing
knows
is-
our, in a sense, it's kind of eerie sometimes that the LLMs kind of know our rules better than we do.
I honestly, I think it might be of questionable value, like if there's too much determinism issues there, like, or like too much chaos.
There's
Because
definitely
like, what if
that.
what if you like maybe switch the order of two functions? If you run the LLM, like, will it produce the same formatting result? Or if you, I don't know, rename a variable or whatever, like.
The
The thing is, like, you don't want your LLM
Right,
to
but I
like mess up
think
your
part of
entire
the
Git
goal
history.
of reformatting is being able to identify the things that you don't screw with, and you carve out as a, like, this has been formatted this way on purpose, and some, you know, I'm detecting columns, I'm detecting things lining up, so I'm going to, it's not violating any strict rules. It's not how I would choose to indent it myself, you know, based on these defaults, but it's not violating any rules. Therefore, you know, so for example, I see the columns, it's going beyond 80 or 100 characters, which is that's supposed to be my cutoff limit. If I'm at Google, you know, I reject code submissions with lines longer than 100, I think. Right. But like, okay, I see the columns, it's going past 100. I realize that they're using that horizontal space to make this more readable. If I change that formatting, I'm going to screw this up completely. And so you carve out exceptions based on things you detected.
All right. We'll look forward to the implementation.
Okay, next topic. Maybe
Yeah.
about something about compilers. Maybe.
Something not to do with code formatting, maybe. Or we could call it quits.
Should you distribute source code or should you distribute bytecode?
Yeah, definitely.
I think JavaScript gains a lot by the fact that the language that you distribute JavaScript in is the same. The API and the ABI are essentially identical.
What's your goal?
But there are things like a closure compiler, which make the JavaScript unreadable.
Too much, Adrian. Holy crap. Not seen my Emacs editor window? Guess not. Can't.
I used to work in 40 by 17, so.
Ow.
Oh God.
Yeah.
I did 80 because IBM punch cards.
I did 40 by 17 because 8-bit CPUs.
But it sounds like a Commodore 64.
Yeah, roughly. Yeah, same chip. Same chip,
Okay,
6502.
I definitely did Commodore 64, which you're right, was short and shorter. But I think it wasn't 40, but it wasn't 17, it was like 24 tall. I don't remember, it was weird wide, yeah. Fine. It might have been 64 wide.
So the main trade-off I see is when you write code, you can't get away from the fact that an API change is a breaking change. If I change the names of the functions and there's code that calls those functions, it's broken now.
Yep.
If I convert my code to something other than the strings with names in them, then suddenly I can have something where I didn't do an API breaking change, but there was an ABI breaking change, and now I have to recompile everything.
Yeah, that's Unison did. They escaped alpha naming. The function doesn't have a name, so they're maybe identified by the I forgot the name for the identification, but basically the function doesn't have a name. So the names are externally, like in a database. So you can rename it, you can attach more names, so the code stays the same.
They have to identify across compilation units.
Yeah.
It's Git. It's the Git of programming languages. Everything's a hash.
Yeah, it's a hash. But
so it's content addressed. I think that's the word.
It's a ridiculous idea, but it's a cute experiment.
But does it make code distribution easier?
So Aaron, I think the answer is you distribute both the source and the binary together. And that's what
So I have a different view on this. I think JavaScript's approach is the right one. You distribute code in source format because there are many advantages to that. But you know, I know that that's not a popular view, but I think a lot of real issues happen in deploying code because of packaging into binaries. So
As
Change
a
is
You can still
hard.
package source. You just have a bunch of text files that get zipped up together into one artifact that you then run.
Yeah.
You have two,
Actually, it's interesting because you mentioned, I think I saw you mention in the chat that you can actually distribute Python as a zip and that runs. I had never heard of that, but
Yeah,
Wow.
so there's two features of Python that interact with each other. The first is if you point Python at a directory instead of pointing at a file, it will check to see if there's a __main ___ in the directory and assume that's what you wanted to run. The second one is if you point it at a zip file, it will unzip the file and treat it like a directory. And the third is that if you pipe code in to the interpreter, it just interprets the code. So you can combine these three features and say, I have a file that starts with shebang bin env python 3. And then the rest of the file is the concatenation of a zip file in it that will all get piped into the Python interpreter that will be treated like a folder, and then it will run main in the folder.
like you.
So when people refer to something as a Py app, usually what they mean is it's a shebang and a zip file with all of the code in it. So that the shebang tells you which Python interpreter to grab.
So you run a shell script and immediately you're running Python.
Right. So now you're just /the thing.
Right.
And it runs.
So am I?
And it knows whether it's Python 2 or Python 3 because the shebang told it which interpreter to use.
So let me just see if I understand this. It's a text string prepended to a zip binary?
Yes, it is the concatenation of a text string and a zip binary.
You never done shell hacking? Come on, this is de-rigor. This is the normal.
That's a standard bash thing. That's not even Python being weird. That's just standard the way bash works is
That's right.
Okay.
you have hash and then bang and then a path and then a new line.
Yeah.
It will pipe whatever is in the rest of that file, text or binary, into the interpreter.
Yeah.
Okay, I had no idea that's how it actually functioned. That's
all kinds of stuff. Yeah.
So, yeah, because actually the funny thing is that accepting that, which sounds like kind of like coincidentally works well and it wasn't something anybody designed, Python's like code distribution system, despite being source, is a complete clusterfuck and it's terrible. And I really I don't like using Python simply because code distribution is and like dealing with different interpreters and all that stuff is so awful.
What's wrong with the Python distribution? Everyone's got their issues, but
well, you kind of have to create these virtual envs everywhere, and there's these. It's just like
it's in one sentence. It's worse than C and C++, which is pretty impressive.
Really? Wow.
I'm just going to start using zip files from now on.
An exe file or a .com file, and you're done.
Right. So that's why I want to go one step further than that Python app thing.
Yeah.
I want to concatenate all my source to the developer build toolchain and tell it the entry point is the thing that's in one binary. So now I can distribute one thing that is both the interpreter and the program.
Well, so you have to pass the. Are you interested in passing a pre-compiled code, or are you expecting a JIT to run? JavaScript runs a JIT.
So I would say it's a matter of the density that you need. That
okay.
By default, you would have, here's my tool chain and here is my code. But if you were willing to have a slightly bigger binary, you would say, here's my tool chain and here's my code and here's all the precompiled artifacts for some set of architectures. And you either get a bigger binary that has a shorter startup time, or you get a smaller binary that has a longer startup time. And that's just a flag on your build that says, well, what are you trying to build?
Gotcha.
Plus, it's nice to have the ability to unpack it and say, hey, toolchain, unpack yourself back into the directory so I can
so the shell script needs
look
to
at what all these files are and
needs to figure out which piece he's firing off. And I guess he fires something up first. The shell script runs something that is in a generic language that picks which target binary I'm going to grab. out of
Right. I would say you start in an ELF file because ELF files have headers that say,
yeah.
here for this operating system, for this architecture, jump here.
Yeah. Okay.
And that's enough to get your tiny stack of interpreters that's just like, here's my tiny little fourth-like interpreter for x86 and my tiny little fourth-like interpreter for ARM and for RISC-V.
Yeah.
And the operating system reads the headers of the ELF file and jumps to the appropriate thing. And then that can just start reading the code that interprets the JIT, that then JITs the JIT, that now you're off the races.
Hey, Yasser, isn't it past your bedtime? You're muted. You're muted, sir. You're still
Sorry,
muted.
is that a question from me?
Fire.
Sorry, who was that question for me?
Oh, no. I was telling Yasser, I was making a joke about Yasser's sleep hours, and he can't get his mute unmuted. And then I was going to tell him he's 2 hours late, but he probably knows that too. He has to go
Probably
reconnect.
sleep deprivation.
Right.
But yeah.
He's got to do a reconnect. He's got a sound issue.
I don't know. There were a few applications that I've gotten in the past that did this trick where they put 4 different architectures all into the same binary, and you just got a giant binary.
Yeah, I've done it before.
Which
didn't Apple do that?
I think that's much cheaper if the thing that you have 4 of is the tiny little interpreter that runs the not type safe version of your language, whose only job is to get the real JIT going.
Yeah, a long time ago in a galaxy far, far away, I was programming a 68,000 base system with EPROMs. You had 4 EPROMs, each one did a byte to give you your bytes for your instruction coding. And you had to program them with a wrong byte slice of each of the 4. And we made so many mistakes where we would just get them flipped after programming them. You pull them out of the programmer and you put them on the board, slap them down, hit code. You got in the wrong order and you have to shuffle and get the wrong order and you forget, so you wipe it out and make a new one with the right order. We finally went in and had to start a sequence that took any of the combinations of the 4 bytes was a valid 68,000 instruction that would eventually jump to a thing that knew what order those chips were in. Then it would read the rest of the memory, copy it, and byte flop it on us. So we could put the chips in any order and it would just run. All right, Yasser, you're still muted.
Yeah, but this time it's on purpose.
Oh, it works.
Yeah. Yeah, apparently it like auto blocked my microphone, so I had to fiddle with the settings and restart it.
Well, what's life? What are you gonna tell us about?
I've been doing the whole like machine nodes thing basically.
Yeah.
Yeah. So
wait,
it was
compilers. Holy crap! We're talking about compilers now. Wow.
Yeah.
You missed an entire meeting of not compilers.
Sir, this is Wendy's.
Are you doing a CM Nodes compiler? Yes, sir.
Yep.
What
yeah,
what's your
I've basically
project?
dropped everything that isn't C of nodes at this point. So like that's my only IR.
I'm telling you,
What
the
is
zombie
your
apocalypse, the Cliff zombie apocalypse, it's coming.
Yeah.
So you're doing machine nodes.
Yeah, I started with the premise of like, okay, I want to do something kind of like what LLVM's got this thing called selection DAG, which is like for instruction selection, and I was like, oh, I want something kind of like that, and then I like thought about it for a bit, and I was like, okay, the things that they get out of it are like this partially ordered graph of nodes for like machine ops, and I was like, I could do that in the current graph if I just made machine ops.
Yep. I did a Burj translation, and it was not worth the trouble, and I would never do it again. I would just do a greedy grab on machine ops. Yep.
Yeah.
So you have this working.
I have some of it working. I don't have the register allocator hooked in, so like I can print out like what the instruction selection looks like, but it doesn't yet run.
The C2 machine description file, one of the good things is it gave me a place to hang all the registers to go with all the machine nodes.
Yeah.
Is machine ops different than assembly?
Yeah, they're like normal C of nodes nodes. They just they represent like some pattern of machine code.
Right.
Like usually it's like one instruction or so, but yeah.
So presumably you have a pretty print that dumps out the actual binary bits, so you can dump it in the buffer. Yeah.
So one machine node might translate to multiple machine instructions.
Technically, yeah. So you might so like one of the common cases, I guess, is like the if. Like a branch might be like I might put the compare and jump like together.
Yeah. I didn't, but you could. But I do like I want an atomic something or another, and I need a lock. I need a CAS and a short trip count for spin,
Yeah.
and then save and jump to slow path. And I might put that as a machine op because it's got complicated ordering criteria and atomic updates and stuff like that.
So,
But most
so
of them for me were all one to one.
I'm curious, are you doing the machine op selection before or after scheduling?
So it's before scheduling. So the idea is like I'll just walk the graph, rewrite the nodes, and then say, now that I've got these, I've got like better like notions of latency and stuff, which means that I can feed that to the like schedulers. So like GCM can now know whether or not something should be hoisted because, oh, this is more expensive than this, and like, yeah. And it has a more accurate description once it like knows what the instruction looks like. And then I do the local scheduling, which right now is an RPO walk, but I'm working on a list schedule. I think I have one that works actually. Yeah, no, it does work. At least it did on the thing that I'm testing on.
Yeah, I just had a simple RPO walk for my local scheduling as well. It wasn't very good, but it did the job sort of.
Yeah.
For you, I would have thought work list would have paid a little more off. You know, x86 is x86 not doing SIMD, not doing AVX. Work list is kind of a little bit.
Yeah, I think it's almost there. I think the big thing that I wanted was like, or like from the list scheduler is like, if you have like a really expensive op, start that first and then get to other things.
The main one is loads.
Yeah.
That have latency. And so if you've unrolled a loop that does a whole lot of array math where he does a bunch of loads because he's unrolled, and then he does an individual element math and a bunch of stores. After aligning to a cache line, you want all the loads up front so they can all run in parallel with each other.
Mm-hmm.
And do you do any like when you're doing the translation to machine nodes, are you value numbering them as well?
Yeah, they're still all technically, yeah, they still have value numbers because they're all in the it's in the same graph. I basically just don't run I don't run the normal like people optimizer because it doesn't work anymore. All of the rules for it are just like built on like the normal nodes. So like they don't run, but technically I can still GVN nodes and I do that sometimes. So like if I have like casts, for instance, I might run into like, oh, I rewrote this node as like a cast, and then I rewrote this node as a cast, because there's like little things that I'll sometimes like peephole while I'm doing the rewrite. So I might potentially do GVN at the same time. So I'll just like, how do I explain that? I think the case that I ran into was like I had like a move SX or something, and it popped up in 2 different places. So I just like started running GVN on it, and I can run that right after the rewrite.
Yeah, there's no harm or difference or anything. It's all the same stuff.
Yeah. I still have all the like edges, including the memory edges, which is the other big one, which is that I know when like 2 loads or 2 stores are parallel, for instance.
Yeah, you keep the memory edges. Yes.
Yeah.
It's all good.
Yeah.
So are there peepholes that you have to run at a higher level of abstraction before you start lowering all your nodes to machine nodes?
Yeah, so like
and how do you ensure that those happen in the right order and you don't sort of lower to machine loads too early and cut off peepholes that you wanted to get done?
It's basically just like there's like phases to it. So there's like general optimizer. So like you might have like a breakdown of like general optimizer, and then you have like the target dependent stuff. So like in the general optimizer, I'll run all the normal peepholes, I'll run the loop stuff, which I think I only have like upscale like induction variables right now. But that's where all that stuff goes. And then after that, you run like the rewriting pass to convert into machine nodes, and then you do scheduling and so on. So I just finished all
So
of
is
the
it fair to
generic stuff
describe
first.
it as run all the peepholes till you run the work list down to nothing?
Yeah.
Then add more transforms and do it again. Then add more transforms and do it again until you're done.
Yeah, basically.
That's certainly how C2 does it. Or the add more transforms, the major one after the peeps are settled is loops.
Yeah.
Peeling loops and range check elimination and pre-post loops for those kind of things. Partial, whatever. irreducible loop rotation and stuff like that.
Yeah, I need to get around to some of that stuff. Oh, I do have an inliner, but it doesn't have a heuristic yet, so I don't like use it at all.
That's a big one.
I can copy graphs is basically what I can say.
Right.
And I have like an SEC walk on a call graph.
Okay. You definitely want to ponder. Do you have whole programs? You doing whole program analysis? Or you got?
Yeah.
Ah, okay. You have any frequency data? Because that helps with inlining a lot.
Not yet, but I could collect it.
Okay. But yeah, inlining's like, one of the big ones.
Yeah.
You're doing like C code, right? This is like an LLVM replacement kind of thing.
Yeah. It can do other languages. So like Shaw uses it in like a more like function level style because he's doing like a mini VM, which is a bunch of like Lua. So like he's doing basic block versioning. So it's not traces. It's like you take a bunch of basic blocks, you figure out what the types are for it, and then you do you stitch them together when you realize that like, oh, this basic block that has these types goes into this one all the time. So you stitch those two together and compile them together.
So
and then
have you thought about
hoist
just running your inliner without heuristics, just inline everything? And for small programs, it's reasonable. Of course, you need, but you can.
You can
I'll consider it a really
heuristic.
stupid heuristic, like just like if it's got less than this many nodes or something, or like.
And you have to not inline yourself infinitely.
Yeah, that too.
Yeah. So that was the one rule that I made for myself. Seemed to work.
You try writing factorial, and oh look, the inliner's still going.
Yeah.
But it was really efficient.
Yes. The encode, yeah, sort of.
Yeah.
Twitch. Yeah. Well, actually, I was going to wind down shortly, and you showed up at the last second. I was like,
yeah.
But I have to say, Debiendo. How do you pronounce your name, by the way?
That's right, Debiendo.
Debiendo. Yeah. Well, the simple project's been really helpful and useful for me. So. Yeah, nice work on that.
Yeah. I mean, it's been great for me as well. I'm still behind the curve because Cliff and I don't know what's his real name is, Exmilia.
Nick something, yeah.
Is it? I mean, he's very sharp, and I've been kind of still catching up.
You're missing some formal theory.
Yeah, indeed. And also, I'm still catching up with some of the peepholes and. Yeah, it's gone much better than I had hoped. So
I'm still waiting for Symbol to become the most popular language to come out of this club.
I'm sorry? Be the only right.
I'm still waiting for Simple to become the most popular language that comes out of this club in the way that Lisp never really got around to the M expressions.
Yeah, we don't have function calls yet, so we're a little out yet. But
you probably are going to need the function calls to really break
we probably need memory, loads and stores, arrays, structs. But
yeah,
those
I think that's going to be the next chapter, right?
Take your pick.
Your plan for Simple is to have only fixed length structs and fixed length arrays. If you want to build something like a vector or a list, build that in the libraries.
The way I see it, our goals keep moving. So I think as we do more, we get more ambitious. So
right. I think we should do the non-moving obvious implementation structs and arrays, because everyone understands how they work, what they're supposed to do, and then you can see how they work in the graph. Now, once you get a little past that, then you're into like, oh, are we doing methods and objects with an implicit this pointer? Oh, we're going to do single inheritance. Oh, you more and more and more. You can decide what you're going to do there, right? And suddenly you can build an array list, and then okay, now you got a moving array if you want one. But do you want to go there? We'll see. I
would say no methods or objects in the compiler. Do that in the standard library.
I would go, no, you can't do objects. I'm sorry, methods and objects you might go do in a standard library. I was thinking you were saying no memory allocations, but yeah. Yes, we're not ready to rename it complex yet. It's Adrian. All right. Yeah, I think memory, and I think calls, and it'll actually be a usable language. And we have to have a path to produce something that'll run, other than, Nick did a really nice C of nodes direct evaluator, but we need to go generate code. And I think the easy answer there is we'll generate something like C and walk away and not do a whole machine code layer. But We'll see. As
Well, the advantage
Stu
of
says.
generating C is that your CFFI becomes a little bit easier.
Yeah, yeah. But you know, we'll play the game as to where we want to, what we want to do next when we get there. See if we want to press on one way or another. So I think the original goal was C of nodes, and we're missing some key bits, be memory and function calls, and then I think we've got most of the obvious bits of C of nodes in place. And then after that, figure it out when we get there. Maybe figure out how to make it a book.
Yeah, I guess the scheduling is also important, right? From C of nodes to some linear format.
Fair. If we have any kind of output, then we have to document it, and any kind of output will require scheduling. That's the global code motion pass.
Yeah, so I think once we get to that, then we are kind of complete from a C of nodes perspective.
Yeah. You know, the demo like Gas was doing with machine code shows you can do more, but it's not necessary in my head to show what goes on with C of nodes. That is yet one more thing hopefully you figured out by then you can go do those kind of things that are straightforward.
Yeah, like it's not that other people don't do like their fancy partial order graphs, it's that they don't stay in them actually.
Yeah, right. We want to show staying all the way out to the end and then spitting out C code. But we could have a machine code variant that was just spit C code, but leave it as a notion that could do x86 as well.
Well, you could do the first book
at that point.
simple and then more simple.
I'm sorry?
You can do simple, the first book, and then more simple, where you can actually go to.
It's the complex book.
Right, and you can play games. Just because you're generating an x86 backend doesn't mean you have to use more than a dozen x86 instructions.
Yeah.
Like you just make an x86 backend that says, here are the few RISC-like instructions that we're actually going to generate.
Yeah.
And
no,
that's what we're generating.
That's what C2 started with.
I think I did some like stats collection on that before, because I sat on somebody's like me and some friends like sat down and we were like, how many instructions are just like mobs? And I think we ended up with like it was like something like 20 or 40%. The next one was like the next closest one was like add or something, which I think is because of the epilogue. Because every time the epilogue would like free, it would do an add, and then you'd end up with like subtract as well, and then add was more likely than subtract to pop up in a function. So then you'd end up with like add was above, and then you'd have subtract or something like that. But like those were like some of the most common, and then LEA as well.
LEA is just a 3.
So how many instructions do you actually need for a sane target?
It's probably around
more
20.
than a dozen.
Yeah.
The
20.
That IU compiler course that I did ages ago, it was the NanoPass style compiler. That from week 1 went all the way to x86 assembly. That was its target. And so week 1 you had x86 assembly with I don't know, like 5 or 6 different types of ops that were necessary just to like get started, and then it built from there. But it was a really nice approach actually.
That's interesting. Yeah, we're building up a graph and adding more technology to the graph to handle more things like memories coming, as opposed to taking a very simple program and going straight to x86 and then add features that go all the way through the compile chain out to the x86. That's interesting. But
yeah,
I'm not a professional.
It started with everything stack allocated. So there were no, there were no variables in registers. There were a couple of fixed registers that it used, and it would just load into a register A, copy into B or whatever, and do everything that way. And that was all. And then later it got like on chapter 3 or something, it did the register allocator. It was very early.
What kind of allocator?
I kind of wish that my compiler
it's the allocator that I've still been using. It's move biased graph coloring allocator.
Oh, it is a graph coloring allocator. It's not a linear scan.
Yeah.
Wow. So you build an interference graph.
Yeah.
Wow. Okay. I mean, you did it.
That's a really good chapter in that book. It has the course instructor wrote a book. And yeah, you just had to build the PDF of the book, and that register allocator chapter is very, very good, I would say.
Excellent.
Yeah.
Interesting.
I was able to read that, watch his 1-hour lecture, and build my whole register allocator.
Okay, cool.
Yeah.
All right. Anything else? We're approaching my witching hour. All right.
I have something interesting, but I wanted to show it actually maybe in a few weeks or so. But I stumbled upon some problems with, I don't know, like so basically I was working on a single pass compiler, but I wanted to improve the register allocation a bit. So I opted for a very simple IR, but it's not SSA based. Yeah, it's yeah, basically I have some like small data structures for like liveness and virtual physical registers and so on. And what I notice is that my language supports nested function declarations and closures. And the thing is, as I'm going through my, as I'm compiling a function to this IR, I keep a certain set of like information about this current function that I'm compiling in a context. And the thing is, once I enter a new function declaration, which is nested, then everything before needs to be somehow like removed or just like, I don't know, spilled somewhere and then later reloaded.
Yes, you have a prologue and epilogue and a function call.
No. Yeah, what I'm talking about is like the data structures in my compiler. So as I'm compiling through a function, I have some information I track about it. But if I now enter a second nesting level, then like I don't know what to do because I want to avoid dynamic memory allocation.
Make a stack. You're doomed. Make a stack. You look at almost any recursive descent compiler, they'll carry a parallel stack to recursive descent. That's the environment or the scope or the symbol table or whatever. There's some variation of the same thing. Simple does it too. There's a hash table for this lexical scope. And if you miss in this hash table, you have to go up the stack and look in the next lexical scope and you search for your variable hits up the lexical scopes.
Right. Yeah, I do that with scopes and symbol tables.
Yeah, it works for functions. Just carry through.
Yeah, the thing is, right. Yeah, I guess that works. It's just there's a lot more like with scopes, they're a bit simpler because I can still maintain lots of information. Like inside of a scope, the previously defined variables are, I mean, they're still valid, but like, yeah, there's other things. I also have like some form of effects system, like yeah.
I do memory effects in scopes. I do IO and outside abstract interpretation, abstract IO effects and scopes. Same as a normal variable.
I just want to avoid dynamic memory allocation and have memory grow too much. This is kind of like
you're doomed
issue
with
because
well, you don't have to do dynamic. You can make, if you're recursive, you put it all on the stack. Your explicit stack is wrapped or carried along with your implicit execution stack in the compiler. You call down into a nested, I'm going to do a nested function. You pass along the prior scope as a pointer to the parser's call, I'm doing a nested function. In the nested function, you put on the stack a new scope for this function, and he has a back pointer to the prior guy, so you can look out of your scope and you carry on. So you've embedded an explicit scope in the implicit control stack scope. No dynamic allocation outside of the stack.
I'll probably rewatch the demo and think of your sentence because I didn't understand it.
Okay, fine. It's way simpler than you're thinking, or you're making it more complicated or something. There's nothing deep going on here.
I see. Yeah, probably like maybe I'm not expressing my problem like correctly, but
okay,
yeah,
maybe I misunderstood.
Simple.
I'm answering the wrong question too. So there it goes.
Yeah, this stuff is all very fuzzy because like I'm changing a lot of like architecture in my compiler. So
yeah, well, you have one pass too. That's kind of exciting. Fine. So throw it on Discord. I mean, go to Discord and even sort of thread if you want. We can go talk it out.
Nice.
Yeah, this is what it's for. You got access to people who know how these things should work. Use it.
Yeah, I think, I mean, like, yeah, we discussed on Discord, like what kind of optimizations have a good bang for buck kind of thing. Like, so inlining, a good register allocation, loop invariant, and stuff. So I guess that was already a good pointer for me. So that's why I've been exploring it. I just have like I set up a few nice regression tests, and I just want to stay. I did notice I did some like small performance tuning a bit in my compiler, like very little, and now I can compile like 10 million lines of code, like 250 megabytes of like source code with a C style code. Yeah, to RISC-V, and I actually. Yeah, I'm hitting actually like 50% of runtime speed of Clang or Dash or Zero. So yeah, it's not that bad.
Yeah, okay. I getting there.
Yeah, but it's very, very RISC-V specific. So I'm pretty sure like once I'm on a register starved architecture like x86, probably this is not
x86
gonna
is
go
no
well.
longer register starved.
No, but it has less general purpose registers, right? Like
not anymore.
Yeah, we're getting close to finally having 32 general purpose registers.
Yeah.
There's no hardware with it yet, but like it's around the corner. So I imagine next 5 years we'll probably get an APX processor, which will be kind of fun.
Oh, you're talking about APX? Or...
What year is it?
No, I was just guessing like 5 year span before we get like an APX. But like they already showed the spec for the whole like APX stuff. I think I read it at some point. I guess key takeaways are 32 GPRs. The only annoying thing is that the instruction encoding has gotten so massive. We have like I think 4-byte prefixes at this point, which is like no longer a prefix at that point.
It's just ludicrous.
You want to have the diagram for it because I have it.
Oh, that's right. Yeah,
that sounds like an epic instruction set.
Yeah,
epic's the right word. Yes.
Sounds like the LLVM of ISAs.
Yeah.
And always the.
I sent you the link, Cliff.
Oh, you put it on the chat. Let's see here. Is it in the?
By the way,
in there.
actually,
all right, hang on.
Does anyone have a good reference that's useful for the RISC-V instruction set?
Yeah, the like just the spec, the unprivileged ISA ASCII doc PDF, which you can download on GitHub.
So if you scroll down, I think it's EVEX stuff. It should already be
the
current.
VEX stuff right here, right? Here's extended VEX. Isn't this it?
Yeah, I think so.
I think that's updated.
Yeah, because the EVEX is supposed to be like the Rex 2 that they added.
Yeah. Right. It's another one, but it gets you the higher set now.
Yeah, because AVX 512 also did like 32 registers, except they did it for the XMMs.
Right.
Yeah, these prefixes are massive at this point, and like at this point, if we're gonna have that massive of prefixes, we probably should just like go back to RISC. Like RISC would get you 4 bytes or 4 bytes in instruction with 32 registers, and not do this.
You know, if it's just an encoding problem, we can live with it. It sucks.
I think we've lived with it for too long at this point.
Yes.
It's a sunken cost at that point.
Yep.
Yeah.
Yep. All right. Now I'm going to start calling it. Adrian, go ask on Discord. There'll be plenty of people piling to help. Me included. But I'm not the only one. Okay. I'm not looking at it. More links. Just throw them in the chat. I mean, throw them in the doc. Last second, all kinds of stuff still showing up. All right. Well, this is a good meeting till we meet again next week, and maybe on Monday I'll be live coding again.
Oh, nice.
All right. Bye.
Bye.